Welcome to FMA 0116 Mathematics 1 Chapter 6 Polynomial. In this chapter we're going to cover what is polynomial. Second, we will learn about remainder theorem, factor theorem and zero of polynomials, and the last part will be partial fraction. So what is a polynomial? So in a polynomial, our input of x or our variable x, okay, the power or the exponent of our polynomial all must be whole number. Okay, so what is whole number? Whole number start from 0, 1, 2, and 3, and so forth. So this will be the whole number, and the coefficient are all real number. Okay, so look at the example over here. We have a 5 different expression. So when we look at the first one, we have an x square, x, and x0. So the exponent or the power will be all the whole number, and then the coefficient are all real number, so it is a polynomial. So we look at the second expression, 2 over x. 2 over x, or our power is x minus 1. It is not a whole number, so then it is not a polynomial. Then the third one, although over here we have a theta, theta normally is a real number, so it is an polynomial. And then the fourth one is third x. Third x is x power of half, so it is not a polynomial. And then the last one over here, we have an exponent x. Exponent x is something that x itself is the power, so it is not fall into the category of polynomial. So next, we look at the common type of polynomial. So how we want to write our polynomial? So normally we will be writing our polynomial in a standard form where our terms are ordered from the highest exponent to the lowest. So example, we have an x3, then the next one is x2, then x0. So from the highest to the lowest. And what is the degree of a polynomial? Degree of a polynomial, it is, we look at the highest power. Okay, the highest power of this one is 4, so it is a degree 4. So the highest power of this one is 3, so it is a degree 3. Okay, and then the number of the name of the this type of polynomial. So we have a constant, linear, quadratic, cubic, and the quartic. Okay, so now before we look at the equity of polynomial, so we look at the operation on the polynomial. So operation on the polynomial, as usual, we have a plus, minus, multiple, and then how about the division? Division will be covered in the next slide. So how you want to sum, subtract, or the multiple of the two polynomial is just you are okay, especially plus and minus, we are looking at the same what's the thing? It's the same power. Okay, so since over here my gx is negative 5x squared, so I just writing as my negative 5x squared plus 1 plus with my hx is 2x plus 1. So this 1 and 1 are same power, so I'm going to have negative 5x plus 2x plus 2. Okay, what if let's say my hx actually will be 2x squared plus x 2 plus 3x plus 1. So you have no need to worry. We just compare. This is the 2x, this is the 2x squared. So we're going to have our negative 5 plus 2. This is for x squared. Then plus with this one 3x. And the last but not least is 1 plus 1. This is the 2. Okay, so finally we have a negative 3x squared plus 3x plus 2. Okay, so what is you going to have a, let's say you have a 3hx. Okay, so what is 3hx? So we get 3hx, it will be, I take my 3 multiple with 2x plus 1, so I'm going to have a 6x plus 3. Okay, then the rest you can do it by yourself. Okay, next we're going to look at is a gx multiple with hx. Okay, this is the one you already learned very long time. So 5x squared plus, then we have the 2x plus 1. You expand it normally. Okay, so we're going to have a negative 10x cubed. Then plus with my negative 5x squared, then plus 2x plus 1, okay? And I just tidy up, so it's negative 10x cubed minus 5x squared plus 2x, okay? Sorry, plus 2x plus 1, okay? So this is a GH and XX. If you want to do the HXGX, so we just swap these two, then you will be getting the same answer. So, okay, over here, the first remark is telling you that gx multiplied hx is not a composite of the two function. Okay, so in your chapter 5, you learn the composite function. We write as a GHX or G not fx. Okay, over here, this is a multiply of two different polynomial. Okay, and now the question asking you, do you think 3 and 4 will bring any difference in the answer? So the answer is no, because you are just expect normally. Don't get confused with our matrix. A multiple B is not equals to B multiple A. That is only valid for the matrices. Okay. Now, next we look at the operation. The last operation of our polynomial is division. Okay. So when you want to divide a polynomial. Okay, so before we look at the division of a polynomial, we look at the normal. Let's say I have a 17 divided by 3. So I'm going to have a 15. The balance is 2. So normally, okay, so the 2 we say it as a remainder. And then this 3 we say is a divisor. And this one is our quotient. Okay, now how you rewrite back this thing in the form of multiplication of the remainder divisor. So we have a 17 equals to 3 multiple 5 plus 2. Okay, so this will be the one in the left hand side, the formula. Our normal polynomial will be our quotient multiplied by our divisor plus with the remainder. Or if you take every of this one, okay, every term, if you use the divisor dx and then dx, so these two can cancel off. So we will have a px divided by dx equals to qx plus rx over dx. Okay, and one thing you look at here, our remainder, the value of our remainder is always less than 3. So over here for the polynomial, the degree of our remainder is always less than our degree of the divisor. Okay, so we look at the first example. Okay, the first example, you want to divide x cubed minus 12x squared plus 30x minus 17 divided by x minus 7. So remember, just now we already said that we use let's say 17 divided by 3. So our 17 is inside, 3 is outside. So same thing here, x cubed is inside and then the x minus 7 is outside. Okay, now how you want to get the first multiplication? Okay, there are two ways. One is you took the highest degree is x cubed and then the highest degree of your divisor is x. So you use x cubed divided by x, so you get x squared. So you will putting x squared here. Okay, or the other way to look at it is x multiple what is equals to x cubed. So I know that is x multiplied by x squared will give me x cubed. Okay, so it's either you want to follow this one or you want to follow this one. Both are fine. Okay, so now when I don't know that I have an x squared, so what I need to do, I just put x squared here. So I use my x squared multiple to both terms. Okay, so I will get the x cubed minus 7x squared. So I written here. So I use x cubed minus x cubed is 0. Then I use negative 12 minus it become plus. So negative 12x squared plus 7x squared will get me negative 5x squared. And then this one, since there's nothing, so it's 0. So I copy back my 38x minus 17. Later on, okay, so now we look at this one. Okay, so now the first term, the highest term is negative 5x squared. So this is the highest also x. So I need to multiply with negative 5x. So I get my negative 5x squared. And then this one multiplied here, I get the positive 35x. So I just minus, so I get my 3x minus 17. Then I repeated this thing. This one, the highest is 3x. So this one is x. So I need to multiply by 3. So I got my 3x minus 21. My remainder is 4. Okay, now do you need to carry on? Okay, whether do you need to carry on? You look at this one. This one, the degree is 0. And this is degree 1. So the remainder degree is less than the divisor, so you can stop. So if you want to rewrite back, you can rewrite as x squared minus 5x is the quotient plus with the remainder divided by the divisor x minus 7. Okay, so now we look at the second example. It's by x squared. No, nothing to be nothing different. Okay, now the only thing that is over here, they highlighted to you, you can add the 0x power of 4. Okay, this one is an optional. Whether you want to add or doesn't, you don't want to add, it doesn't matter. It's just to avoid careless mistake. So now we look at this one. The first one is 7x power of 5. This one is x squared. So 7x cubed multiplied by 7x cubed multiplied x squared will be giving you 7x power of 5. And then you multiply for each term. So you got it. And then you minus. And next, you are looking, the first one is negative 14. So you need to multiply with negative 14x squared. So you give you negative 14x squared. And you repeat it until where you can stop. Okay, so when you can stop, this is degree 5. Cannot stop. This is degree 4, this is degree 3, this is degree 2, and this is degree 1. Finally, this is the degree 1 is less than the degree 2. So you can stop here. So you can rewrite this one. Okay, now the next example, okay, this example is just to show you that is the quotient not necessarily must be whole number, okay? So let's say you have a 1 over 2x power 4, so or we can say it's x4 over 2. So we multiply by x over 2, you will get x4 over 2. And the process is still the same. And you need to always checking when to stop when your degree of the remainder is lower than the degree of the divisor. Okay, so this one is the exercise which I'm going to discuss during the class.